robot has been designed. Nobody would just sit down and start building a robot like this on day one. But yeah, so today we're working on the electronics. So I had an intern, a student who designed these relatively simple printed circuit boards. And then over here we have some little light sensors, which are one of the two types of sensor that this robot's going to be equipped with. And this morning I've just been attaching wires to them so that we can hook them up to the main circuit boards using these little screw terminals over here. And yeah, so today basically I'm hoping to hook up the motors, the batteries, the sensors and the circuit boards so that essentially we have the nervous system of the little robot ready to go. And then from tomorrow we're going to start making the parts for and assembling the physical structure.
I'm actually cutting a material called continuous cast acrylic. That's what I'm cutting at the moment.
Okay, so today we've started the sort of physical manufacturing for the robot really. So yesterday I successfully put together the whole circuit, though I haven't tested it yet, fingers crossed, that's a job for tomorrow I think. And so today we just got finished laser cutting the 3 plates that are going to be stacked together to form the main chassis of the robot, and in a minute we're going to go through to the 3D printer room and load up the files there for printing the outer shell, which will be completed over the evening and be ready for us tomorrow morning.
So it basically it starts off as an ink, it sprays the ink into the cross-sectional positions where it needs to be for each layer, and then as it sprays that ink on, the UV light comes across and changes the ink from being fluid into hard material, so it hardens it. It'll then add the ink back onto that, it'll go across again, and then it'll cure it to make it hard, and eventually it builds up and stacks up to the final component.
So the 3D printing is taking longer than I'd sort of initially anticipated and will only be ready for tomorrow morning. However, what I have done today is I've completed the assembly of the electronic circuit, and I've put together the main internal chassis. You can kind of see there's a lot of wiring and gubbins inside there, which is obviously all going to be enclosed and covered up. Also, we don't yet have a head on which to mount the left and right proximity sensors and the left and right light sensors. But huge relief, I was broadly able to test the circuit today, and it works. Maybe not perfectly, but quite well, and hopefully I'll be able to iron out the remaining issues. But yeah, so it's shaping up well. I'm now quite confident that we will have a working robot by Friday morning. And so stay tuned for the last installment tomorrow. So the 3D printer had finished its print this morning. It was waiting for us, just needed to take it out of the machine and then use the high pressure water wash to clean off all the support material, which left us with this very nice glossy finish over here. And then it was just a simple case of fitting it over and bolting it onto the chassis. Fortunately, the electronics pretty much worked straight off. There was a little bit of tweaking required, but that didn't take too long. So most of what I did today was finishing the assembly, attaching the sensors to the front of the shell, putting the shell over the chassis that you saw yesterday, and then just testing it and getting some footage of it doing its thing. Success, really. So we now have a finished robot. So yeah, mission accomplished. I present to you our completed robot.
Okay, well, it looks like a sort of semicircle of white, and then it's almost like a figure of 8 with a smaller at the top bit.
Use some imagination. It's obviously a ladybird.
Oh, it's a white ladybird,
yes,
obviously,
yes.
With a black flat top and
Yeah.
2 red wires poking out at the top, and some little black bits sticking out at the front. It does look like an insect of some kind.
Yes, indeed, and that's appropriate because, in a loose sense, its nervous system, so to speak, and its behaviour is vaguely reminiscent of that of insects.
Right. So, how long did it actually take you in real time?
It probably took about 10 hours of my work, 20 hours of the 3D printer's work, and about 5 minutes of the laser cutter's work. And that was on top of 2 months of input from 2 student interns who'd been sort of designing it in the background before we got started.
Okay. Now I understand there has to be ceremonial switching off of lights by
yeah.
our producer Rob here, so that I can see the glories of this.
Yes,
lovely
that
picture.
will simplify things. So the robot has 2 types of sensor, one of which is a light sensor, and the other is a distance sensor. So we're going to use the light sensor for simplicity today. So by connecting the wires in a particular way, the kids who will ultimately use it will be able to set it up like this to be attracted by light. So I'm shining a torch in its eyes, and as you can see, it is quite reliably steering towards it.
That's
When I
scary.
turn off the light, it goes quiet. And then, whoop, there we go.
It's just going round and round where your torch, you're pointing the torch at it, and
Yep.
that's the light it's responding to.
Yeah.
And you've made it go round in certain directions.
Yes,
without
so at the
touching
moment
it.
it's moving towards the light, and if I was to simply switch these 2 wires the other way around, now it's going to be kind of scared of the light instead.
Oh, and it runs away from it. Oh my
Yeah.
goodness.
So basically we're going to be trying to sort of teach 10, 11-year-old children the core concepts of behavior and AI in a very, very, very simplified form that will hopefully be accessible to them.